Alrighty, CNT140, we're continuing on with Chapter 7. The next area, they talk about different cabling types. They give a very generic, kind of like a little generic thing on each cabling. Hopefully you remember some more than what they showed you here in from 120. But real quickly, let's put some context to this, or a little bit more meat on it. If we look at our standard, we see that there's three types of recognized cabling that we can use. The 100 ohm balanced twisted pair. We just got done talking about a bunch of that. Multi-mode cable and single-mode cable, and they give you some specs on the multi-mode. We'll touch on that a little bit more when we get to the fiber chapter later. But those are the three that are recognized for use in our cabling system. Well, again, let's put just a little bit more to that. Our 100 ohm balanced twisted pair, that's our category 6 and so forth. That is typically going to be used as our horizontal cable from the closet out to the work area for the user. The other two, multi-mode and single-mode, multi-mode will typically get used as our backbone cable between closets in our building, less than roughly 500 meters. There is some different distances I can use there depending on the type of multi-mode cable, but that's kind of a ballpark. So multi-mode cable is typically going to get used in our building as backbone between our closets. The last one they mentioned is single mode, which I can use as well. That is typically a backbone cable, again, between closets or switches when I need to go more than 500 meters. We can actually get a handful of kilometers with this one. So single mode fiber, I like to mention if you come to Wildwood for classes, one of the main wiring closets for the college is in the Blocker building. Well, if Blocker goes to connect to the buildings around it, the hall tech and the bookstore and the student center, they're all less than 500 meters. Multi-mode cable could work to connect those buildings. But if I need to connect up to the North Hall, that's where they have the fire tower and the fire safety classes and that sort of thing. From Blocker up to North Hall is more than 500 meters. You really only have a choice of single mode to connect Blocker up to that North Hall. So if I'm going greater than 500 meters, single mode, I have options. It can get me distances if I need to. So that's why those three show up on the list of approved, and that's why I'm kind of addressing them that way, and that's kind of their applications. So I show you here again. Here's your closets in a multi-floor building. Horizontal cabling is typically going to go from here out to the user, and that's typically my copper cable. I'm going to use my category 6 UTP, if you will, for that. Meanwhile, between my closets is typically going to be fiber optic. And as we've discussed more than once, for bandwidth, for distance, I know that's not great distance, but if I need to across one side of a warehouse to another one, I have it. But it's also used between my floors because fiber optic is made of glass. Glass is an insulator, so if I have an electrical short here on this floor, it won't travel through my backbone cable down to here and do damage to this switch, because this fiber optic is a glass insulator between these floors. So that is good for electrical isolation between my floors. And I kind of remind you the same thing here. From my patch panel out to my work area outlets, copper horizontal cable, the cable going between my switches, fiber optic typically. That's what I'm going to run into. They mention wireless, and they give you a quick bullet point here about with wireless, no real need for cables for individual terminals. That's correct, but I do need to have a cable network for my access points back to my closet. And they say there's three main problems with wireless: standards, bandwidth, and security. So first, let's kind of put a couple of these pieces into play. Here'd be maybe a network that I have where I have firewall, router, switch in a closet that I'm going out to some workstations with phones, and I should say I'm going out to somebody's desk where they have a phone and a desktop. Well, these runs here would all be category 6 UTP copper connection, horizontal cabling. As I'm connecting in my wireless access points, here's one, but there might be 3, 4, or 5, they're going to connect into my switch as well using a copper horizontal cable run. So when I deal with a wireless network, I still have those concerns because I do need to cable them into my network. And here will be another example too, just showing a couple access points plugging into my switch here. So I do need cabling for my wireless network. And they talked about three problems being standards, bandwidth, security. Well, standards have come a long way. We have 802.11 standard, and in there we have, you know, A, B, G, N, AC, etc. There's lots of updates to it over time. So as long as we're planning things to a standard and deploying things to a standard, a lot of the problems we used to have with wireless goes away. I'm not going to say all of them, but a lot of them go away. The next one they mention is about bandwidth, and actually with the advances of wireless over time in multiple input, multiple output channels, we can get, you know, 2, 3, 4, 500, 600 meg bandwidth or throughput with 802.11n, 802.11 AC. I can get a couple hundred megabits up to a few gigabits. So again, bandwidth has come a long way with wireless. The other one they mentioned is security. Well, again, in the early days with web, that was very easily crackable. We've come a long way with WPA, WPA2 with security, securing our wireless networks. Again, they still have, you know, you still have to put wireless access points in VLANs, limit where they can go, have security, have encryption, have logins, everything else. It is a concern, but it is something that can be dealt with. It can be dealt with. One thing they didn't mention was Power over Ethernet, which we've mentioned before, but I'll mention again for you. From my switch, I typically am going to power the access point from my switch. That way the access point can be placed in my building where the coverage is best, not where it happens to be near an electrical outlet. So the power for the access point is actually coming from my switch. Hopefully you remember that from before. So my switches need to be capable of Power over Ethernet. Here's one that has a couple ports. Here's one that has a couple more ports with Power over Ethernet. And they even show you, this even says it's a Power over Ethernet switch, and they show you what ports are being powered on some of these with the little blinking link lights. As I'm speccing out switches or buying switches, I'll see as I look at a bunch of different model numbers here, here's a couple models that are not capable of powering. Then here's a couple down here that have different power wattage ratings. So you might need to do some homework on the model numbers and what they are to know what capabilities they are. And I might also need to do some homework on the access points I'm using. What are they going to draw for power? So if I look up, this is just a kind of a, I think this is like an 1800 Cisco WAP 1800 blah blah blah, kind of an everyday access point. This is using 15.4 watts if you're going to use Power over Ethernet. Well, I do my homework and find out, okay, this draws 15.4 watts, this can support 390 watts, so I do my simple division and find out this switch can support about 25 access points, or access points on about half the switch. So I might need to do some homework on Power over Ethernet to make sure that my wireless network is being supported or powered by my switch. The other one, other method they mention here is infrared, pulsive infrared. This is kind of a derivative of what we have been using for remotes for television for a long time. Inexpensive, short distance, line of sight, etc. Okay, there are some applications to it, or for it. They talk about Powerline carrier networks. Yep. And actually, I think we might have even talked earlier this semester briefly about this. This actually does have some use in a home. And I actually pulled this example up because this is a good example. If I have a wired network here on the first floor and I don't have an easy way to get a wire to the second floor, instead of relying on wireless up here, I can use these power adapters. One plugs in down here to your router and plugs into the power outlet. It sends the signal, modulates it to go across the power line upstairs. The other adapter up here pulls it off and rebroadcasts the signal to laptops up here and or to a power ported device up here. So it basically uses the electrical wiring in your house as a path for my data signal. And that's basically power broadband over power line, BPL. That was something that was brought out as a technology, did not get widely deployed for ISP connection due to interference with certain radio frequencies that were being used, but has adopted little uses like this for homes. And I know people that successfully use it in their home to extend their network. It does work. They also mention in here microwave. Microwave is another technology that's a line of sight. And you all, for the most part, recognize microwave connections. You've seen them, may not realize. One thing you do need to worry about with microwave is usually you're in the wavelengths where you actually have to have an FCC license to be doing this, and or permissions or permits to be able to use a microwave link between two sites. But here's a common example. If you've ever seen a television truck, here's a television truck with a big boom going up. This is more than likely a microwave transmission or microwave uplink truck. What happens is you'll have a truck here that's reporting news from a special event, maybe a special football game or a special hockey game or whatever. They'll set this truck up, take the boom up, that way it gets above trees and buildings. They aim this dish at a tower that's on a mountain somewhere nearby, and hits one of these microwave antennas up here, one of these microwave dishes, and then this can turn around and rebroadcast over the mountain back to a television studio, back to the home studio, if you will. So we've all seen microwave links in the form of like a live television truck. Hey, we're going to go live to blah, blah, blah. That's where you've seen that. And then you've all seen these dishes on antennas before. That's what those are. Those are microwave links, and that is direct line of sight. As long as you have a direct line of sight above trees and buildings, you can make that link. Alrighty, we'll come back in the next podcast, continuing on.